This is chapter number 8, Gravitation. Escape velocity. As the name suggests, to escape, what should be the velocity and what is the velocity? The escape velocity on Earth is the minimum velocity with which a body has to be projected vertically upwards from the Earth's surface so that it just crosses the Earth gravitational field and never returns. This means that Earth is here. Say it has some gravitational field. Now with what minimum velocity, least velocity, a body has to be projected vertically upward so it crosses this gravitational field and it never returns back. So this escape velocity of any object is given by V sub E under root 2 G capital M by capital R. This is under root 2 GR, which can be expressed in this expression also. So the escape velocity, it doesn't depend on the mass or shape or size as you see in the expression. Not even because the direction of projection of the body is also not important. So escape velocity at Earth is 11.2 km per second. There are some important escape velocity you must know. For Moon it is 2.3 km per second, Mercury 4.28, Earth as I said 11.2 km per second, Jupiter 60 km per second, Sun 618 km per second, neutron star 2 into 10 to the power 5 km per second. So what is the relationship between V escape, that is escape velocity, and orbital velocity? The escape velocity is equal to under root 2 times the VO, that is orbital velocity. So if the velocity of projection is equal to the escape velocity, that is V equal to VE, then the satellite will escape away from the Earth using, or from the planet using a parabolic path. And if velocity of projection of satellite is greater than the escape velocity, that is V is greater than VE, we just have known V when it is equal to VE. When it is greater than VE, then the satellite will escape away following a hyperbolic path. Weightlessness. What is the weightlessness situation? You might have seen the astronauts, they are just floating around, so they are feeling no or less weight. So this is a situation in which the effective weight of a body becomes zero. How this weightlessness is achieved? When you are falling freely under gravity, you are inside a spacecraft or a satellite. If you happen to reach the center of the Earth, and when a body is lying in a freely falling lift. Kepler laws of planetary motion. First is the law of orbit. Every planet revolves around the Sun in elliptical orbit, and Sun is at its one focus. So if I can make it a bigger one, this is an ellipse. Then we have this as the major axis, this as the minor axis. So we have, for ellipse we have two focus or foci, you can say, one here, one here. Then the first law says, which is the law of orbit, that every planet revolve around the Sun in this elliptical orbit when Sun S is at one focus. This is known as the perigee or perihelion. This point is known as the apogee or aphelion. The planet is nearest to Sun at perigee. It is farthest from Sun at apogee. Then the Kepler, another law, which is law of area. The radius vector drawn from the sun to planet, it will sweep equal areas in equal interval of time. This means the aerial velocity of the planet around the sun is constant. Means if at t time it reaches from this point to this point, this is the area. Okay, so the radius vector drawn from the sun to a planet sweeps equal area. If for the time, say same time t, this is the area, then these two have to be equal. This is the law of area. So aerial velocity of a planet, dA by dt, area per unit time, in terms of derivative. This is L by 2m, which is constant. L is nothing but the angular momentum and m is the mass of the planet. Law of period. This says that t square is directly proportional to a cube, or you can say r cube. The square of the time period of revolution of planet around the sun is directly proportional to the cube of the semi-major axis of its elliptical orbit. See, in this case, this is the major axis, so this half is the semi-major axis. This whole is B, you can say 2B. This is minor axis, so the half of semi-minor axis, or you can say half of minor axis, is semi-minor axis, which is B. So if you consider from this point to this point as 2a, this is the distance we are talking about, a. So t square is directly proportional to a cube. So you can say for t1 time, if it is equal to say k a1 cube, for t2 time we have again k a2 cube. So if you divide these two, t1 by t2 whole square, this is square, is equal to a1 by a2 whole cube, where a is the semi-major axis of the elliptical orbit. Some important points: a missile is launched with velocity less than the escape velocity. The sum of its kinetic energy and potential energy is negative. The orbital speed of Jupiter is less than the orbital speed of Earth. The bomb explodes on the moon. You cannot hear the sound of the explosion on Earth. You will not be able to hear it. A bottle which is filled with water at 30 degrees centigrade and fitted with a cork is now taken to moon. If you open this cork at the surface of the moon, then the water is going to boil. For a satellite orbiting near surface Earth, we have orbital velocity as 8 km per second, time is 84 minutes approximately. This is approximate. The angular speed is this much, 0.00125 radian per second. The inertial mass is given by force upon acceleration, F by A. The gravitational mass is given by the weight of the body divided by the acceleration due to gravity. They are equal to each other in magnitude. Gravitational mass, this one, of a body is affected by the presence of other body because it is because of the gravitation. This inertial mass of body will remain unaffected by the presence of other body because it remains the same wherever you go in entire universe. Let us summarize. The Newton law of universal gravitation is stating that the gravitational force of attraction between two particles of mass m1 and m2, which are separated by a distance r, has the magnitude F equal to g m1 m2 multiplication divided by r square. This g is universal gravitational constant whose value is 6.672 into 10 to the power minus 11 Newton meter square per kg square. If we have to find, say, a resultant gravitational force which is acting on a particle, say m, due to number of masses m1, m2, mn, so we are going to use the principle of superposition. This F1 to Fn are the individual forces which are acting on this m1, m2, mn, and each will be given by the law of gravitation as you saw here. From the principle of superposition, each force will act independently and will be uninfluenced by other bodies. So what will be the resultant force? It will be given by the vector addition from F1 to Fn, which is given by sigma, that is the summation from 1 to n, all these from m1 to mn forces, summation is Fi. So it goes from 1 to n, Fi. The Kepler's law of planetary motion, these are very important 3 laws, that all planets, they move in elliptical orbit with sun at one of the focal points. So this is the elliptical orbit, this is the sun at one focal point, all are moving like this. The radius vector from the sun to planet sweeps equal areas in earth at equal time interval. That means from this point to this point, I say from this point to this point, this is t time, this time t time, this moves from this point to this point at t time, this moves from this point to this point at t time, this area will be equal to this area. So this follows from where? From the fact that the force of gravitation on the planet is central. That is why the angular momentum is conserved. The square of the orbital period of a planet is proportional to the cube of the semi-major. If you take from this point to this point as 2a, this will be a. So t square will be directly proportional to the a cube. So the time period t and radius r of circular orbit of a planet about the sun is related by this expression: t square is equal to 4 pi square by g into ms into r cube. This ms is the mass of sun, and most of the planet have nearly circular orbit about the sun. And when we talk about elliptical orbit, this equation is valid if this r is replaced by the semi-major axis, that is r is replaced by a cube. The acceleration due to gravity, there are 2 scenarios. One above the earth, one below the earth. Say this is d, depth. So this, say at height h, above the earth's surface, this gh is a function, that is gravity is the function of the height, is given by g into me by re plus h. Me is the mass of earth, re is the radius of the earth, h is this height, which is eventually given by, because we can ignore that height if the re, that is radius of earth, which is 6400 km approximately, is very large, then h, you can ignore this. So this equations become g into me by re square into 1 minus r2 into h by re. So gh is equal to g0, that is g, which is a function of h at this point, and at this point, that is at 0 point, this will be equal to 0.1 minus 2h by re, where g0 is simply g into me by re square, because the height is 0. When you talk about coming down or below the earth crust, the depth d below earth's surface, now the g, again the function with respect to depth is given by g into me by re square 1 minus d by re, which is like this, is equivalent to g0, that is at 0 depth 1 minus d by re. The gravitational force is a conservative force. That is why the potential energy function can be defined. The gravitational potential energy is associated with 2 particles m1 and m2, which are separated by r distance, which is given by this relation v. We represent it by v minus g m1 m2 by r. V is taken to be 0 when this R reaches infinity. If it is infinity, this is going to be 0. So the total potential energy of system of particle is what? Is the sum of energy of all pair of particles, and we are taking the pair where each pair represent a term of the form which is given in this equation. So this prescription follows also from the principle of superposition. If you talk about an isolated system, so if an isolated system consists of say particle of mass m, this moving with certain velocity v in the vicinity or nearby the massive body, say this m, the total mechanical energy of the particle will be given by E equal to half mv square minus g capital M small m by r. This means that the total mechanical energy TME is the sum of kinetic energy, this is kinetic energy, and this is potential energy. So the total energy is a constant of motion. If this m mass moves in a circular orbit of say radius a about this mass m, and this mass m is very large as compared to the small m, so the total energy will become E equal to minus G capital M small m by 2a. Now here is a choice of arbitrary constant in the potential energy. As we saw in the previous point, the total energy is negative for any bound system, that is one in which the orbit is closed, that is elliptical orbit. So the kinetic energy and potential energy is given by the kinetic, this is the total energy. Kinetic energy is given by Gm capital M small m by 2a. This potential energy is given by G capital M by a. If you combine them, you get this energy only. The escape speed for the surface of the earth, VE escape, is given by 2 into capital G capital mass M of earth, capital RE radius of earth, which is eventually equal to under root 2 G RE. This has a value of 11.2 km per second. If a particle is outside a uniform spherical shell or solid sphere with a spherically symmetrical internal mass distribution, this sphere attracts the particle as though the mass of the sphere or shell is concentrated at the center of the sphere. If a particle inside a uniform spherical shell, the gravitational force on the particle is 0 if it is inside here. If the particle is inside a homogeneous solid sphere, the force on the particle acts towards the center of the sphere. So this force is exerted by the spherical mass which is interior to the particle. The geostationary, we have geosynchronous communication. Geostationary satellite, they move in a circular orbit in the equatorial plane. Means if this is Earth, this is the equatorial plane, they move in this plane, equatorial plane, as the approximate distance is around 4.22 into 10 to the power 4 km from the Earth center. So we have certain physical quantity, the symbols, dimensions, unit and remarks. The gravitational constant given by capital G, the dimension is this much, and the remarks is the value is this much. The gravitational potential represented by V, and which is a function of radius. This is given by minus capital G capital M small m by r, and this is a scalar quantity. The gravitational potential is given by minus G capital M by r, which is a scalar, and because it is this is energy, it is in joules, and this is a potential, so it will be per mass, so joule per kg. The gravitational intensity represented by capital E, or you can say sometimes Eg also, is given by G capital M by r square, and we have a unit vector along this direction, so this is vector. So this is the gravitational concepts. Thank you so much. Take care of yourself.